Hey, South Carolina's math industry, and we are going to get to work on the work problems. So, in this video, we're going to have some fraction busting again. But this time, we're going to try and see how we can use that strategy in real life. And we're also going to find out how it applies to real life. So, if you're running a business, or if you want to know how long it would take to do something, or if you want to know how long it would take to do that or this, then this is definitely going to help. Here is the story problem. A high school is preparing for a robotics meet. There are some game fields that will be used that they will be using to set up. There are two teams preparing, the B team and the E team. The B team can set up the field in 6 minutes, while the E team can set up the field in 12 minutes. So, when there's a robotics meet, each team has a different number and a different letter, according to which team they are, so people don't confuse themselves which is which and who is who. Not only that, when we take a look at the field that the robots are going to be played on, the field is very large and it covers 144 square inches, and it takes a while to set up. That's why some teams can actually do it in 6 minutes, while some other teams can actually set the entire thing up in 12 minutes. This is what the field looks like. So, the main question to solving this problem is, how long would it take to set up the game field if both of the teams work together? That means if the B team can set it up in 6 minutes, and the E team can set it up in 12 minutes, what would happen is if they would work together. But we want to know how long they would work together for, and how long they would complete the job. What we could do is if you try to estimate how long it would take to do it together, some people would take the average. 6 plus 12 is going to be 18. Divide that by 2 is 9. 9 is a pretty good estimate for how long it would take. But when we try and use the method for fraction busting, it will solve the problem. Not only we solve the problem, but we're going to be dead accurate. So technically, we're going to hit bullseye. Approximately, it would take that long for both teams to work together. So before we do the math part, we actually have to make our equation. Since this is a word problem, we have to get some details from the word problem and see if we can make an equation. Let's start with the example. So here is a blank piece of paper. We already know that we have to have an equal sign and have 1 over x on the bottom. The reason why is the 1 is going to be the number of fields. And the x is going to represent the time to complete the task. So the letter X is going to represent how long it would take both teams to work together. We have 2 teams, right? Then we have 2 numbers that have to go on the left side of the equal sign. In fact, they're going to be used as fractions, and we have to add them because if they're working together, they're going to be combining their 2 forces to work together. So, we said that the B team can set up the entire field in 6 minutes. We can put B on here to remember it. If they can finish the entire field in 6 minutes, we're going to have a fraction of 1 over 6. Then we have to add the E team's effort. E for effort. Get the joke? If they can complete the entire field in 12 minutes. So we're going to put 12 right here. The problem is, what is x? So here we have our equation. 1 over 6 plus 1 over 12 is going to equal 1 over x. Now we have to find out what the letter x is. So that happens when we do fraction busting. Let's start busting the fractions. So we're going to put parentheses around here, and here, and here, and here. The next step is we have to find something that is the least common factor. Then we can divide it, but we'll have it as the greatest number. Since we have a 6, a 12, and an x, all of these can be divisible by 2 at the least. But since we have an x, we have to divide everything by x. The 12 is the biggest number. So we're going to put 12 right here and 12 right here. Our goal is trying to create another one. We're going to try to create another expression that is easier for us to solve without fractions. That's why it's called fraction busting. So the 12 is going to attack this and that and that. So when we do that, we destroy them. So 12 divided that by 6 is going to be 2 times 1. 2. But there was a problem. X is a denominator. So we have to add 12x right here. So instead of it being a 2, it has to be a 2x because x kind of changes everything. It's a denominator. So we have to add that by 12. X divided by 12 times 1 is going to be x. That's going to equal 12. X divided by x times 1 is going to be 12. So we have a much easier equation to handle with. 2x plus x equals 12. We no longer have the fractions because they're busted. We can combine the 2x and the x to make it as a 3x. 3x plus 12. What is x? Divide by 3. Divide this side by 3. And x equals 12 divided by 3 is 4. X equals 4. So right here in the equation, that letter x can be equal to 4. If they did work together and they set up the field, it would take 4 minutes for both of them to work together to complete the entire field. That is a little bit off with our estimate. Doing the average is a good way to get to an estimate, but you don't know if your estimate is actually that accurate. But if you do fraction busting, you will actually get to how long it would take if they both work together at bullseye, like really, really accurate. So approximately, it would take both of the teams 4 minutes to work together to complete the field. Let's see an actual robotics meet and see it in action. Ready?
Over there on the blue side, you guys ready to play this match? You good? Say yes. Over here on the red side, say yes. Here we go. On time is 3, 2, 1, go! Those are touches, so they don't count. So red's going to win by
by one ring.
Wait, but it's touching what?
It's touching the hook underneath it.
Oh.
3, 2, 1, go!
Come on, you got it! Yeah, let's go Clawbot! Someone! Warning! Let's go! Oh, touch him, touch him! Got it, Clawbot! Now, go! No! Oh, reverse! No! No! Oh! That was an awesome match! And that is how we can use fraction busting in real life. So the next time you want to know if you and your partner or your team or another team wants to work together and they want to measure how long they can do it, you can use fraction busting to approximately calculate how long both of you would work together for and complete the mission. I hope this video has helped you. Thank you for watching Tao Ping Life's Math Industry. Like and subscribe. And if you're into robotics, I recommend you joining it because you get to battle and make robots with your friends and the world.